Fantastic. I'll let you take it away then. Thanks.
All right. So I am Martez Reed. The talk is on authenticating to HashiCorp Vault in a VMware vSphere environment. A little bit about myself. I am currently a technical education engineer at Puppet. Roughly a little bit over 10 years of IT experience. The primary focus on automation, orchestration, and the whole DevOps thing that people are doing nowadays. A couple of ways to find me and connect: LinkedIn, Twitter, GitHub, some of the usual options. And so authentication in HashiCorp Vault. So one of the phrases that often comes up in terms brought by HashiCorp is the notion of secure introduction. And so the challenge with secure introduction is, how do you introduce a secret to a system to essentially authenticate, but also keep that initial secret secure? And so in this the slide, it's showing a key. So how do you get the key to the lock? In most scenarios, if you're the one that originally rekeyed the lock or bought the lock, the key comes with the lock. But in scenarios where, let's say, it's a third party that you somehow need to give the key to, how do you give the key to that third party in a secure fashion? In the case of people's homes, some people go the route of hiding the key under their rock. As most of us know, that's not a very secure method to pass a key to another individual. And so that's the challenge that we have, is how do we hand that key off to someone else? Or oftentimes in the case of IT and automation, is how do we hand that off to a machine to actually be able to authenticate with our HashiCorp Vault? And so that brings us to different Vault authentication methods, such as there's really two types that fit into that all authentication types fit into these sort of buckets. One is human, the other is machine. And so in the case of the human, you have things like username and password, GitHub, LDAP, some of the common ones. In the case of machines, TLS, AppRole, and then as well as the trusted platforms like AWS, Azure, Cloud Foundry, and more. And so in the case of a VMware vSphere environment, we might use AppRole. So AppRole is an authentication method that allows us to essentially take two pieces of data and then combine them when it ultimately gets to the target. So the first piece of data is the role ID, and the second piece of data is the secret ID. And then once those two are combined, it allows our entity, whether it's a VM or even technically it could be a human, to actually authenticate to HashiCorp Vault. And so in the case of a VMware environment, you might utilize something like VMware vRA, as well as VMware VRO, Realized Orchestrator, as well as Realized Automation, to actually handle the initial delivery of the role ID to the virtual machine during the provisioning process. And so that gets us half the way there. Is we've got the role ID to the system. Now, how do we get the secure ID to the system to allow the system to complete the authentication process with Vault? And so in this case, it might be leveraging something like Puppet, configuration management tool, to handle the process of bringing in that secret ID. And so once that's done, it then enables the system to combine both the role ID as well as the secret ID to pass the HashiCorp Vault to handle the actual authentication process. So this is one method that would be applicable to VMware environments for provisioning. Another method, and oftentimes people may refer to it as quote unquote more cloud native, but is using a tool like HashiCorp Terraform to actually perform the provisioning process and then populate the role ID on the system to allow it to have that first piece of data. To accomplish the second aspect, you might leverage something like Puppet Bolts to perform the actual orchestration of grabbing the secret ID from HashiCorp Vault and using it to populate to the system as well. And so this would allow the system to now have both pieces of data, which is the role ID as well as the secret ID, that would be combined for the actual authentication against the system. And so with a configuration management tool, like an Ansible or a Puppet Bolt in this example, we could then essentially take that a step further and leverage HashiCorp's Vault agent that handles auto authentication to actually simplify the configuration on the virtual machine itself, to actually provide that token to the system. And so what something like a Bolt or an Ansible could do is during the actual process of laying down the secret ID or populating the secret ID on the system, it could also handle the installation of the Vault agent as well as deployment of the configuration file that specifies where the Vault instance is, along with where are the role ID file as well as the secret ID file. And so what that does is allow the system to now have access to HashiCorp Vault, a Vault instance, and leverage an Auto-Auth agent provided by HashiCorp, and then allows our applications to go through a simpler process of integration and not have to worry about the actual authentication piece, as well as renewal and things of that manner. And so in this case, we're offloading the capabilities of the authentication piece to the Vault agent. And with a configuration management tool like a Puppet, Bolt, or an Ansible, we then are able to simplify the actual deployment of that and reduce the complexity that we have. And so that was one of the first common methods, is the AppRole. The other construct within HashiCorp Vault for authentication is what's known as a trusted platform. And so what that does is allows a external system to act as an identity provider for HashiCorp Vault. So that way the system presents identity information to HashiCorp Vault, and then Vault utilizes a trusted platform, such as one of the ones on this slide, to actually perform the validation or verification of those identity, essentially credentials. And so walking through that, an example would be a machine needs to authenticate to AWS. It fetches the identity information from the metadata service. It then passes that to HashiCorp Vault to validate the actual identity information. Vault verifies the identity with the trusted platform, or in this case, the AWS API, and then provides the token. This is a very high level walkthrough of what the process is. There's a lot more nuance and a lot more complexity, but at a high level, this is the intent of trusted platforms. And so in this case, it may be Azure or GCP or Kubernetes that replaces the AWS in this particular example, but this is how the process works. And so now we have, in the case of a VMware vSphere, so the challenge is that there is no, we're using the service to validate. In this case, who am I would be the question that the VM asks. And then on the converse side, HashiCorp Vault is questioning who is VM01. But unfortunately, the challenge is that there is no metadata service natively available in VMware vSphere to actually provide this information. There have been a number of solutions that have been developed to facilitate this capability within VMware vSphere. One of the ones that comes to mind is the OpenStack integration to facilitate this metadata service being provided to the virtual machines. This is a reference slide or a reference diagram in regards to how that process works. And so as we can see, there's a bit of a challenge here in terms of just the sheer complexity of this process and how it would actually work in practice. So that's one of the challenges of that, is how do you implement a solution like this in a simplified manner without incurring too much administrative overhead. One of the solutions that I've tinkered with is leveraging VMware vSphere guest information as part of the process. Those that are familiar with deploying OVAs or OVFs in VMware vSphere environments are familiar with a screen such as this, where you can customize the template with whether it's network information or configuration information, for the virtual machine to actually be able to pick up once it has booted as part of the process. And so the thought is, how can we leverage this native capability to populate or provide information to the virtual machine that it can be aware of as part of the process to integrate with HashiCorp Vault and essentially mimic a metadata service at the VM level. And so really, this is really what we're trying to do, is how can we pull essentially identity information from the VMware ESXi host for the VM to actually utilize as a quasi metadata service so that it can use that information and present it to HashiCorp Vault. One solution that I've kind of worked through, it's an open source project that I've tinkered with, is a platform I've referred to as vAuth. But what it allows the system to do is be able to create a mechanism that mimics the metadata service. And so this is really a walkthrough of what that workflow would look like. And so the first piece is querying guest information from the VMware vSphere via the VMware guest tools, utilizing the guest information that is similar to what is used for a VApp or OVA or OVF. And so that's a call within the actual virtual machine itself. It has to have VMware tools installed, but it can leverage the RPC communication between it and the host to actually pull that data once the data is populated. The second piece would be trying to authenticate to HashiCorp Vault, leveraging the auth data that we provided. And in this case, HashiCorp Vault would leverage integration with the vAuth platform, which provides an API to HashiCorp Vault to perform that integration. At which point vAuth then queries the database for the virtual machine data to actually perform the validation of the data that the machine provided. In this case, it would return the results, whether it is valid or not valid, to HashiCorp Vault, and then Vault would return a validation response. So in this case, I'll jump to a quick demo of what this actually looks like. And so I've got a virtual machine, a Windows machine running on VMware vSphere. And so what I've done is just created a quick and dirty PowerShell script to actually interact with the guest information that's presented by VMware vSphere to the virtual machine. And so what it's going to do is pull that information out of the guest information and then pass that to HashiCorp Vault for the authentication piece. And so what's actually performing the population of that data is the vAuth platform that I spoke about. And so I'll just run through a quick example of what this looks like. So if I run the script, it then interacts with HashiCorp Vault. And so my Vault instance is running on actually my laptop right now, but it's performing a VMware vSphere login. And so the other component of it is a custom plugin to perform this interaction. So there's a custom plugin loaded into VMware, loaded into HashiCorp Vault to actually be able to talk to the vAuth platform to perform this authentication piece. And so what we can see is that once it's done that process, we can then perform the authentication, and we're pulling back a client token as well as policies associated with that particular token. In this particular case, it's a one-to-one mapping of policies to virtual machines within VMware vSphere. But this starts to provide a mechanism that can be used for authentication, more native authentication in VMware vSphere, similar to the capabilities of the trusted platforms currently provided by the public cloud providers, such as the AWSs, the Azures, the GCPs, and that native capability. And then as we saw, step 7 would be returning the token to the virtual machine to actually perform any subsequent process of fetching secrets or interacting with HashiCorp Vault. And so just a quick overview of what the vAuth platform looks like from an architectural perspective. a number of moving components that perform the interaction. But as we can see on the right side, HashiCorp Vault interacts with the backend to perform that validation of the credentials provided by the virtual machine. There's a scheduler which runs to ensure that all virtual machines have the required data populated for their identity. A syncer performs a similar process utilizing an event bus to inform the worker to actually go out and populate the identity information. The watcher service really just watches for events such as power on virtual machine events within the vSphere cluster to ensure that those machines, as they come up, are being populated with the identity information. So in the case of, let's say, a VRA or VRO provisioning or even a Terraform provisioning, once the machine has been created, it ensures that the identity information is provided. So as part of the bootstrap process, it could reach out to HashiCorp Vault without any issue. And so what this starts to do is allow us to simplify the process of whether it's dynamic database credentials to a Postgres backend. So that way, that process stays the same in most scenarios where it's a simple process. But the challenge in a vSphere environment has generally been, how do I perform that initial authentication to my HashiCorp Vault instance without a lot of overhead? And so leveraging an object storage such as Aminio starts to extend the capabilities of a VMware vSphere platform to start to become, quote unquote, more cloud native and mimic some of the native capabilities and offerings provided by cloud providers. In addition to that, it might be something like leveraging Apache Kafka for a streaming platform to handle actually fetching just TLS certificates from HashiCorp Vault, being leveraged as a PKI server to perform that authentication against the Kafka instance. And so the aim of this is to start to provide mechanisms and capabilities on the VMware vSphere platform that mimic that of some of the public cloud providers to reduce the friction of trying to leverage cloud native capabilities and architecture, even in a VMware vSphere environment. That is the end of my talk. Hopefully it was helpful. A number of different ways to connect and reach me for more information. The information regarding the vAuth platform, if there's interest there, is on my GitHub, Martez R, and the repository is just vAuth.
Sorry, just coming back on there. Thank you so much for giving your talk. I'm just checking to see if there's any questions, because we have a little bit of time if you're interested in doing it.
Yeah, sure.
But I don't see any right now. So if anyone has any, give it like another minute. I'm seeing great jobs in YouTube, so you're getting lots of compliments.
Hopefully people found the vAuth platform interesting, and it's open source. There's a lot of different possibilities for extending it and providing more capabilities.
Hello, Nick. Nick, your mic's not quite working. Oh, no.
Oh, I was just complaining to say I don't know what's going on with my video. I had a question. Just around kind of open source in general, though. What are kind of your opinions on open source in general, and I suppose kind of the open source consumption of software?
Yeah, I mean, I think it's a really great model. I think the challenge becomes, especially in the enterprise space, how the enterprise views consumption of open source. And it provides that sort of dichotomy to the actual creators and maintainers of open source projects. I think there has to be an understanding that obviously it's oftentimes people doing things in their free time and trying to just tinker with things. But oftentimes the enterprise mindset comes into play of consumers, where the thought is it's more so a product than just a project. and you have scenarios where there's complaining and bashing. Unfortunately, that happens to open source maintainers. That's sort of the worst part of open source. But I think the other aspect becomes the opportunity for really great innovation, as well as just allowing for different a really large mind share of opportunities for individuals around the globe to connect to help further causes. I mean, we're seeing that with the Kubernetes of the world and the HashiCorp platforms to continue to drive innovation within the space.
I think that's an interesting point around the innovation. I mean, I've been working in the industry a little while, a little bit longer than my youthful good looks may kind of may let on, but I personally look at kind of innovation and how open source has driven innovation has been like absolutely pivotal. I mean, you kind of turn things back pre-GitHub and before, and I use GitHub as an example of an organization. There's many wonderful companies, but what I meant was it was that community adoption of centralizing on this method of sharing code. SourceForge just didn't kind of work as in the same way, and I think that the software post kind of the rise of GitHub has been just incredible.
Yeah, no, it's definitely taken off. I mean, I think the only challenge that most, I think especially on the enterprise, have seen is just the lack of standardization, which is also one of the drivers of innovation. Is there's oftentimes no one standard that they can say, okay, this is the standard for secrets management, or this is the standard for whatever it might be to kind of place their eggs into that basket. But have to really be essentially agile and understand that oftentimes it's a moving target of as innovation continues to move at a rapid pace, they're going to have to continue to potentially pivot and adopt different open source projects.
Yeah, super interesting. Thanks, Martez. Really, really good. Thanks.
Yep, thanks.
Thanks. And we just have a couple more questions coming in from the YouTube chat as well. So somebody was wondering, they said that they saw in the demo you had Windows assigned, but they wanted to know how you set the policies so that you can limit the access to only what the specific VM needs.
So the policies would be defined on the Vault side. And so it'd be a mapping, in this case right now, 1-to-1. In my case, the virtual machine was Windows base. And so during the process, I would, let's say an example, run during the creation of that entity, I would associate the policy for that machine at that process. So I might grant it only secrets access to a Windows path. And I would associate that policy to the virtual machine during the instantiation process on the Vault side. So similar to other mechanisms where you're associating a policy with the role, it's that same process. And so when the virtual machine goes to authenticate, it then knows what policy to grab.
Perfect. I saw there's a couple other questions and they look like they're rephrases of that. And mostly it's that you did a great job, and you did. So thank you so much for coming on today.
Yeah, no problem.
Thanks.
Thank you.